Welcome to Laws of Indices Level 1. Pause the video now, have a go at the 5 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're simplifying 3x to the power of 6 multiplied by 7x to the power of 4. And because we're multiplying indices together here, we're going to use this law, which tells us that when we multiply indices together, we add the powers. So starting with 3 times 7, we have 21, and then x to the power of 6 multiplied by x to the power of 4 becomes x to the power of 6 plus 4, using our law. Since 6 plus 4 is 10, we have our final answer for problem 1, which is 21x to the power of 10. In problem 2, we're simplifying 24y to the power of 10 divided by 8y to the power of 3. And to do this, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So starting with 24 divided by 8, that gives us 3. And then y to the power of 10 divided by y to the power of 3 becomes y to the power of 10 minus 3. Since 10 minus 3 is 7, we'll have our final answer, which is 3y to the power of 7. In problem 3, we're evaluating 5q to the power of 0, and this means that we need to find its value. Now, because we have a power of 0 here, we're going to use this law, which tells us that anything raised to the power of 0 is equal to 1. This means that q to the power of 0 is equal to 1. So 5q to the power of 0 must be 5 times 1, which is equal to 5. And that's our final answer for problem 3. In problem 4, we're simplifying 50a to the power of 4 b to the power of 9 divided by 10a squared b to the power of minus 3. Now, because we're dividing indices here, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So starting with 50 divided by 10, this gives us 5. A to the power of 4 divided by a squared gives us a to the power of 4 minus 2, using our law, and b to the power of 9 divided by b to the power of minus 3 becomes b to the power of 9 minus 3. And we have to be really careful here to make sure that we realise that these two minuses make a plus. So simplifying this, we have 5a to the power of 4 minus 2, which is 2, b to the power of 9 plus 3, which is 12, and that's our final answer for problem 4. In problem 5, we're told that f to the power of n multiplied by f to the power of 7 is equal to f to the power of 5, and we need to find the value of n. Now, on the left-hand side of this equation, we can see that we're multiplying indices together, so we can use this law, which tells us that we need to add their powers. So the left-hand side of the equation becomes f to the power of n plus 7, using our law, is equal to f to the power of 5. Now, since both sides of this equation have the same base, which is f, we know that their powers must be equal to each other. So this means that n plus 7 must be equal to 5. We can now solve this equation by removing the plus 7, and we do this by subtracting 7 from the left, and also subtracting 7 from the right. Now on the left, 7 minus 7 is 0, so that just leaves us with n, and on the right, 5 minus 7 is minus 2. So we have our final answer for problem 5, which is n is equal to minus 2.